Hey everyone, welcome to Data Millennials. I'm Atul, and in this topic we are going to discuss about the math module in Python and how we can use math module in our day-to-day programming. So let's understand about the math module first. Math module in Python consists of the mathematical functions and constraints. It is a built-in module made for the mathematical task. The math module provides the math function to deal with the basic operations such as addition, subtraction, multiplication, division, and it also provides the advanced operation like trigonometric, logarithmic, and exponential function. In this video, we are going to learn about the math module from basic to advanced, and we'll also study the functions with the help of a couple of examples for each and every function in the math module. So first, let's understand how we can import the math module in our code. In order to import a module, we'll simply put import and then we have to give the name of that module. So for us, we have to give the name of the module as math because we are importing math, and then we'll give an alias saying m. So we are importing math module as m. So if I run this cell, then we won't get anything in our output, but the moment this cell runs, the math module is imported in our code as m. So as we have already imported the math module, we can use the various constants and functions, and let's see some of them. So let's start with the constants in math module. The Python math module provides various constants like pi and tau. So we will be looking at pi, tau, Euler's number, infinity, and nan values. So these are the constants that has been provided within our math module. So let's write some simple code using these constants from math module with example. Okay, so let's first talk about Euler's number. So in our Python program, if we basically write math.e, this constraint returns the Euler's number, which is 2.71828, and the basic syntax is this only, which is m. Like we have imported math as m, so we can simply write m.e, or we can write math.e. So let's write a simple code that imports the math module and prints the value of mathematical constant e. Okay, so I'm gonna remove this and I'm going to import math, and then I'm going to print math.e. So if I run it, you can see that we have the Euler's number over here. Now let's write another simple example to calculate the exponential growth using the Euler's number. Okay, so we'll be using a user defined function for that, in which we'll take the initial value, then we'll take the growth rate and time, and we will calculate the exponential growth. So for that, let's say that I have a initial value equal to 100, and let's assume that our growth rate is 5%. So I'm just going to put 0.05, and then let's give us 10 years. Okay, now in order to calculate the growth rate, we would have to use the initial value, then we would have to take the Euler's number, multiply it with growth rate. That growth rate needs to be multiplied with time, right? So it looks pretty complex, but if I write a function, let's say that I'm writing a function of exponential growth. In this function, if I take the argument initial value, then if I take growth rate and time as my parameters or argument, and then if I basically calculate the final value, then my final value would be initial value multiplied by math.e, because we have already imported the math module, so we are taking the Euler's number directly, and with this Euler's number, so we'll use this double star. This double star is nothing but exponential. Then we'll put our growth rate multiplied by time, and then we are going to return this. Okay, I think I missed a bracket. Then I'm going to return this final value. Now, in order to get this final value, okay, I have done a mistake over here. After return, you have to give this final value. So in order to get this final value, we have to use another variable. Let's say our result. Okay, so we'll put growth result. Growth result is equal to, and then we are going to call this function. Within this function, I'm just going to give the argument, which is my initial value, then my growth rate, and the time. Okay, now if I want to print this growth rate, we can simply say that print slash n, and I'm going to say after this time which we had given over here, this time period with a growth rate into 100% growth rate. So once I'll run this, then you will understand what this print will do basically. So this growth rate, the spelling of this growth rate is wrong, so let me copy this growth rate and put it over here. Now if I run it, you can see that we have the output after 10 time period. Okay, I need to put 10 years over here. Okay, so after 10 years time period with a 5% growth rate, what are we going to achieve? We have to put this growth result also. Okay, so I'm just gonna give another print statement saying that print f the value grows from, so I would have my initial value over here, right? So I'm going to put this initial value over here. So the value grows from, let's say our initial value was 100, from 100 to approximately our growth result. And now if I run it, you can see that we have the output. So the first line says after 10 years time period with a 5% growth rate, the value grows from 100 to approximately 164.87212. We are able to calculate this exponential growth rate because of this Euler's number with the help of this math.e constant. So we can simply import this Euler's number using math.e constant, and we can use it in our mathematical calculations. So it's as simple as that. Now if we talk about pi, let's talk about pi constant in math. So we all are familiar with pi. The pi is depicted as 22 by 7, or we say it as like 3.14, right? But the math.pi provides a more precise value for the pi. So if I run this, you will see that the value of pi is 3.141592653589793. So this math.pi gives us a more precise value of this pi. So let's write a simple code that imports the math module and use the mathematical constant pi in a program. So what I can do is that, let's say that I'll import math, or we have already imported math, so we do not need to import math anymore. So we'll simply say, let's say that we have to calculate the area of circle. Okay, so for area of circle we would need radius. So I'm just gonna say radius equal to int input, and then I'll write please enter the radius of the circle. Now in order to calculate the radius of circle, we basically, the formula is pi into radius square, right? So we'll simply say print math.pi into radius into radius. And now if I run it, then the first thing that Python asks me is to enter the radius of circle. So let's say 5 is the radius of circle, and if I press enter, then you can see that we have got the area of circle. And for achieving this area of circle, or for getting this output, we just have to use this math.pi instead of actually putting the value of pi manually 3.14 or something else. Now let's talk about tau. So tau is defined as the ratio of the circumference to the radius of a circle. The math.tau constant returns the value of, if I run it, it returns the value of 6.283185 and all of these numbers. So let's write a simple code that imports the math module and then calculate the circumference and area of circle using tau. Okay. In order to calculate the circumference and area of circle, we would need radius. So let's assume our radius is 5. Okay. Now we have to calculate the circumference. So to calculate the circumference of circle, we can basically use math.tau into our radius and we'll have the circumference. Similarly, for area of circle, what we can do is that we can use math.pi into radius into radius. So in order to do that, let's create a simple user defined function. Okay. So we'll define a function named as circle properties. So we'll say circle properties, and then in this function we would be expecting the radius as an argument. Then we'll check if radius is less than 0. If radius is less than 0, we'll return invalid radius. Radius cannot be negative because we are getting radius value which is less than 0. Now if it is not 0, or if the radius is not 0, or it is not less than 0, then we have to calculate the circumference. So for that, let's say I'm using circumference CIR equal to, we'll simply say math.tau into radius that we have received from here, which is our argument. Similarly, for area, we'll simply say area equal to math.pi into radius into radius. Now let's return the value. Return this circumference comma area. So already we have declared the radius as 5, or given 5 as a value for this variable radius. Now what we can do is that we can simply say circumference result comma area result equal to this circle property, and within this circle property I am going to pass on this radius argument, and then I can print simply saying that for a circle with radius equal to radius, then again a print statement, circumference is this circumference result. Let me copy this, and area is this area result. So now if I run it, you can see that we are getting the output saying that for a circle with a radius of 5, circumference is 31.4159, area is 78.539186. Now if I go up, you can see that we are getting the same area over here. Over here we had also used math.pi. Over here we have also used math.pi. So it's very easy for us to use the math constant like tau and pi to calculate certain values based on our requirement. Now let's move on to the next constant that we have, infinity. So infinity basically means something which is never ending or boundless from both direction, for example negative as well as positive. It cannot be depicted by a number. Thus the math dot infi or you can say infinity, math dot infinity constant returns of positive infinity, and for negative infinity we will have to use minus math dot inf. So the simple syntax is that you have to use math.inf for positive infinity, and for negative infinity you have to use minus math.inf. So let's write a simple code using the infinity to represent an unbounded limit. Okay, so in our day-to-day life you must have experienced that most often we got a number 0 and we are dividing something with 0. In that case we get the error. In order to handle that, we can use the exception handling, or we can use this math.infinity as a returned value whenever there is a division by 0 occurs. So let's write a simple program to depict that. Okay, so I'm gonna say numerator equal to 10. Okay, and I'm gonna say denominator equal to 0. Okay, so we are deliberately setting this to 0 to show the use of infinity over here in this program. Now I'm just gonna write a function saying that divide or infinity. Okay, in this I'm going to take numerator. Okay, the spelling of numerator is wrong, let me correct this. numerator, numerator. Okay, so we are going to take this numerator, we are going to take this denominator as our argument, and then within this function I'm going to check if this denominator is equal to 0, then you will return math dot infinity, the positive infinity, else you are going to return numerator, this numerator divided by this denominator. Okay, now the next thing that I have to do is that I have to get this result saved into a variable, right? So I'm just gonna give a new variable division result, and I'm going to call this function. Within this function I'm going to give numerator and denominator as an argument. Okay, and let's print this division result. So if I run it, you can see that we are getting infinity. Instead of 0, let's put 2 over here, and if I run it, you're getting 5.0. But the moment you will get 0 as a denominator value, you can see that we have this infinity, which is basically coming because of math.inf constant. So we are deliberately setting this numerator to 0 over here to show the use of infinity. And this is a very simple example to show you how you can use this math.inf constant in your day-to-day program. Now the last constant that we have for this video is the nan values. So let's talk about this. The Python math.nan constant returns a floating point nan, which is not a number value, and this value is not a legal number. The nan constant is equivalent to a float nan. So let's write a simple code that will handle the nan values in your data. Okay, but before that we have to understand that the math.nan represents not a number, which is a special value that is used to indicate that the mathematical operation is undefined or the result is not a number. Okay, so the first thing that I'm going to do is that I'm going to create a new variable user value, and in this user value I'm just going to give randomly 42. Okay, with this user value what we are going to do is that we are going to check whether the value that has been provided to us is actually a number or it is a nan value. Okay, so for that I'm just going to create a very simple function, user defined function, check valid number. Okay, in this I'm going to take the argument value, then I'm going to give a control statement saying that if math dot is nan, this value, then return value is nan, and you have to write information saying that cannot perform calculation, right? So we cannot perform any calculation with nan values. If it's not true, then we have to give the else statement saying that return value is valid. Okay, we are going to say this value and we have to take this value from the function argument and put it over here. So we are saying this value, let's say 42, is valid. Okay, now let's take this returned information and store it into a new variable result. So we are saying result equal to, take this check. Okay, I have done a mistake over here, valid, the spelling of valid was wrong, so I've corrected it. So check valid number and I'm going to give this user value as my argument. Okay, if I print this result, we'll get the value. So if I run it now, you can see that we are getting the output. This value 42 is valid. Okay, I need to write is over here, is valid, right? Now instead of that, let's say that I am going to import random module over here first. Import random. Okay, and then I am going to give this user value as float nan, and let me comment it out. So if I run it now, you can see that we are getting the output value is nan. We cannot perform any calculation with nan values. So this comparison can only happen very easily if you are using math.isNan. Okay, so basically the math.nan does not represent a number. It is a special value to indicate that the mathematical operation is undefined or the result is not a number. So in this video we have seen all the constants that is present in the math module. In our next video we are going to discuss about the numeric functions in math module. Happy learning and see you in the next video.